Good. All right. One of the things I always do is, being a year, I kind of come up with a theme for presentations, and it mutates along the way. So the title's a little different, but I don't think that'll annoy you because it's turned into a workshop, which covers all the principles. And if you're wondering why that little guy's there, the last time I was in this building, that little guy came with me and gave a presentation in front of 3,000 people. He's 13 years old. Gave a presentation in front of one proud father, shout out, the 3,000 people at DockerCon. So gave him a picture of himself. That's kind of cool. So the agenda, what the agenda should be called is how do you do a 4-hour presentation in 30 minutes. But I'm going to go through sort of introduction, a little bit about me. We talked about who I am, what I've done. A brief history of the AI thing. I will tell you, I'm writing another book now. Hopefully be done at the end of the year, which is going to be sort of the history of AI, which has just been brilliantly fun. If anybody's read my Deming book or my previous books, it's like a very Michael Lewis-y way of telling a story. So I'm having a blast writing it. I don't care if anybody buys it or not. And then I'll go into a little bit of just enough of Gen AI. So one of the things the reason I get bored easy, so I find new trends, and I'm sort of a cliche, right? So DevOps and Gen AI. All right, sure. But the other thing too is I really feel like if we're not prepared in what we do, there's a technical debt tsunami coming down the pike for us. And so we've got to get up to speed so that we can do what we do really well, is protect our organizations. Because if we let all these companies just come in and just blow out all these co-pilots and chatbots, and our CIOs coming to us and saying, what do we do? And we're like, I don't know, that stuff's strange. So one of my goals of the workshops, and I've got all the code, I mean, like you can go there and you can run this stuff, is to get our tribe educated. And how do we do this? We use it for ourselves. And then we can be part of the conversation. Now, I'm going to get off my soapbox here a minute, but I've seen this movie. I'm 65 years old. I've seen this 5 decades of this movie. I joke that we're like the operations people. I'm ops mostly. Are like cicadas. We wake up every 17 years and we try to figure out what the mess everybody's made, and we have to clean it up, right? So that's really why I'm doing this. It's more about I hate that we create this toil that creates all this other stuff. Enough soapbox. This is who I am. I've written about. Somebody made a joke. I've started as many companies as I've written books, which is kind of close. I've had 10 plus companies I've created. Sold a company to Docker. Sold a company to Dell. I was. I think 8th person in at Chef, 8th or 9th person in at Chef, here in Seattle. A little old bank is where we started. And I've done, I was also I'm considered one of the founders of DevOps. I was the only American at the first DevOpsDays, started the first DevOps Day in the US, so blah, 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 blah. Did a lot of things. But that's my recent book about Dr. Deming. I'm pretty passionate. 10 years took me to write that. And the reason this book is sort of prominent for this presentation is the way I learned AI is through my book. I used my book. I loaded my PDF to learn out, what is a hallucination? What does it really look like? Because I know it's in my book. So I use my book throughout all the workshops and other data sources as well. But to learn, what was this thing and how do we sort of get a hold of it? This whole, the hallucination scariness, oh my God, it's going to tell me to do something and I'll do it. No, don't do it. You can manage that. And again, that goes back to what we do. We don't let people just throw in LLMs that answer questions and get people killed. And so that's a lot of what this workshop is about as well. I do got to do a shout out for the people who pay me to do a lot of travel. I call myself a fractional evangelist right now, and I've been lucky to find 4 clients that are actually that really fit well in this new generative AI, and they sort of dig my DevOps Gen AI story, but MongoDB has a vector database. Arise is I'm going to talk about observability in LLM world. It might not be what you think it is. They have an open source tool that's amazing. Hedgehog is putting Kubernetes clusters on SmartNICs so that you can basically run boxes GPUs on the edge. Mike Dvorkin, who basically invented ACI for Cisco, is the CTO over there. It's killer cool stuff. And then Acorn are the rancher guys, rancher people. that basically now I've gone all in with a thing called GPT script. And if anybody wants to see that, it's like all open source. It's really cool. I can do an open space on that. There's my book. My kids are already sort of through college, so they like buy it. But like a few years ago, it would have been better. And I have a couple of newsletters that I'm trying to sort of promote. And one is getting prepared for my sort of next book. Attention is all you need is like a landmark paper. I had to take the slide out because I only got 30 minutes, but it is the sort of the turning point. There's a Google paper that like really like how we get to ChatGPT is that paper. Attention, or Google it. Don't read it because get somebody else to describe. Oh, what is going on here? Anyway, so I've been covering that, but I still cover my Deming stuff in my Profound newsletter. So, a little history. This all starts with, like, in my book that I'm writing, really the real stuff that's happening now, and this may change, is all about neural networks, right? And so this actually started with, and this is I won't get too far into history, but these two characters, McCullough and Pitts, like in 43. What's interesting, too, and the story tells how Pitts was a homeless guy. Imagine that. So one of the most landmark papers written that literally gets us to ChatGPT was some brilliant homeless guy he read something from this professor, stormed into his office and started yelling at him that he was wrong. And like McCullough's like, man, wait, you hang out, don't leave, you know. So and they became partners. And if you know Norbert Wiener, there's like really cool stuff there. But basically, when we talk about neural networks, we talk about this sort of the hidden layers. And if you saw that last picture, the idea was like, what does the brain do? Can we electronically try to figure out what the brain might be doing, right? The question now is, are we right or wrong? It doesn't matter. It does like crazy stuff, right? And this is really sort of historically too. And I tell you, attention is all you need, and that's something you should remember and find out more about it, because it's called transformer. The T in GPT is a transformer, which comes from the attention. But this is really important because. And I was like, if you're a Deming person, everything goes back to Bell Labs, right? Jan LeCun, the first sort of challenge, or the first sort of successful commercial neural network was the post office needed to read handwritten digits, right, for zip codes, right? And then NCR needed to read numbers on a check, right? So LeCun took the neural network concepts that had been building and all the way through, and he built this neural network of trying. What they did is they went out and they solicited like 70,000 handwritten numbers, and they basically used this neural network to train to say, if it's this, it's an 8. If it's this, it's a 6. And then now you could feed what they call unsupervised. Like, what is this now that I've walked through and built this neural net? And I'm really sort of going as high level as possible. But the point is, through that sort of, and it wasn't called a matrix, but a matrix, or vector actually is what it's called, a vector of all these things, it would actually predictively say, I think to say, it's all about pixels. And so to go forward now and get movies, it's all about pixels, right? So, and this is kind of cool. There's a lot of tools that will will show you the vector. So this is an important point too, and I'm probably going to run out of time, but the way this data gets loaded into these neural networks is a vector. And so if you think about the word cat and the word dog, right, and this is the numbers, but if you think of the word cat and dog, basically think about if I was going to plot the word cat and dog in a two-dimensional space. The x would be this, so dog would be like 5, 8, right, or 30. If I was going to do three-dimensional, it'd be like 10, 20, 30. And then dog and cat would be somewhere on that Cartesian plane, right? Well, like if ChatGPT by default, it's a 1536 dimensional vector, right? So and if you've ever get to see an embedding, which is basically the position of where it is in that multi-dimensional or highly dimensional space, it's basically 1536 floating point numbers. And then like now you're all going to run because I shut up. But then what happens is one of the base ways is a cosine similarity between the distance in the vector. So if you've taken any sort of like minimal calculus, if you haven't, then I'm sorry. I apologize. But what's really cool is when you start loading this stuff into vector space, you start seeing some, and especially the tools that, there's a lot of open source tools that can sort of visualize this. So this was a hackathon. I've been running these DevOps Generative AI hackathons, right? And they're really awesome. Like, we only invite sort of people that want to do DevOpsy things, right? And we're not giving out prizes, and nobody's becoming a startup. They're really trying to solve real world problems. So this one team wrote this really interesting thing where they vectorized all the commands that they had in history for the last couple of months in their company. And then literally, now you could do things like, what was the command that dumped the Oracle database, that did this? And it's like use a chat GPT model to come back and give you an example of the command you possibly run. Or like, what was the command I ran 2 weeks ago that, and but what was really cool is that was cool by itself, but then what we saw when we visualized it, like you start seeing clusters. So imagine if you had your whole team, and I'm definitely gonna run out of time, but you had your whole team running commands, right? And now you could be saying, like, why is a bunch of people running this command when we have this command available? Like, that's the stuff you can start seeing. And I did it for my book. You know, in my book, I clustered out like Toyota. So it's about Demings, so Toyota. You can see if you know anything about those two characters, TPS and Deming. I saw that healthcare showed up. And so, like, it actually kind of explains to you why hallucinations happen. Because there was no reference in my book about healthcare related to Toyota. But Toyota started out as a loom company. And there was some, the LLMs, as a judge they call them, was interpreting some of the words I used there as healthcare. And you can start seeing how you get hallucinations, because it's all probabilistic. There's no, this is not a deterministic model, right? These things are basically statistical best guesses. They happen to guess really well, though. A couple of things that come up a lot, like what's the difference between machine learning and deep learning? You know, machine learning is a subset of sort of training algorithms. Deep learning is the neural networks. It was coined deep because Geoffrey Hinton, who basically is considered the godfather of AI, he was in an interview once, and he said, it's really deep. And the New York Times writer said, oh, a deep network. And that's why we got deep learning, deep networking. And so here's the thing, going back to my pontification of, like, saving the world. Few people might be close to my age, but remember the lamp stack, right? What did that do for us? Right? It put us all in the same position to try to understand what the heck was all this internet web space stuff, right? We got a nice clean acronym, and it told us, it gave us sort of positioning, Apache, Perl, it gave us sort of positioning of what we could understand. At least for me, it worked, and I think it worked for a lot of people. And I've been thinking a lot. I've been seeing people post their vendor version of that, and I thought, look, what's a generic one that should make sense, though? So, like, if any of you are new to this stuff, maybe this thing can help you sort of understand what are some componentry. Because what the net is, I don't want in your organization to have 100 vector databases next year because nobody asked any question. Because nobody thought that SRE should basically go ahead and say, why can't we just have 2 vector databases? We're really good at managing these 2. And so every time a new vendor, this is what we do for everything else, right? New vendor comes in, like, why do you use that one? We already have these 2. Can you use that one? And if we could sort of scope our conversation around, hey, next time HR wants to bring something in, hey boss, can I be in that meeting? And I can ask a question like, what sort of LLM orchestration engine are you going to use? And I'll go through each one of these, right? What observability? I promise you that I'm going to tell you that observability takes on a whole different meaning than the way we think about it, or at least most people, or I thought about it. And then RAG is probably one of the more interesting things. That's where you sort of get your vector databases. That's how you start controlling hallucination management. And then model providers. And then, like, I originally just called it LORM, but I'm calling it LORM because now you can see the conversation about personal agents or autonomous agents and how you can start. I think that's going to deserve its own category as well. So the LLM orchestration, anybody who's probably heard anything about what's going on, or if you've even seen a Jupyter notebook on any of this stuff, like, you're probably going to see LangChain, and my friend Damon calls it's maybe the Vagrant of in that, like, Vagrant was great for the first 3 or 5 years of cloud, and then, like, where's it now, right? I don't know what's going to happen. I think LangChain is the best way to get started. It does the most. It gets you so far along. It has connectors to like Jira, like you name it, SQL, you know, all sorts of stuff. So it's an easy, you're 101. And again, I'll point to the labs we have, a 101 of like loading your own data in, you know, take some corpus of data, you know, like I did with my book, load it in, run a LangChain as an orchestrator. You don't need an orchestrator. You can orchestrate this yourself. But it, like you'll see, you'll get so much value of like, okay, oh man, I got my first like, you know, chatbot working. This is awesome, right? Llama Index is really cool because it's, I don't know, it's just, most people will run on-prem stuff with Llama Index just because there's a whole, the models associated with it. But the reason I have DSPY first is because a lot of people, like one of the things that like, you know, like I can manage hallucinations and correctness and bias pretty well. I spend a lot of time with a lot of clients doing that. I'll have some slides to show you some skills and where you can do that. But at the end of the day, it is a non-deterministic model. So you're never going to get absolute facts. And so one of the things that the complaints happening now, right, is these orchestration models, the way they do prompt engineering are sort of like, if you're, you know, like every company now, like imagine this, and this isn't a true story, but imagine you're Toyota and you want to basically allow people to have a conversation in buying their car. Like, it's got to be correct. Right, like I want a purple car, but I want this and I want that. Like you have the fine tuning that you have to do with the orchestration models. Sometimes it's not good enough, or it's medical health care, or it's a very complicated service provider. This is a true story. Service provider who somebody's coming in with a business and they want to be able to allow them to sort of let the conversation build the services, right? Like, and so this DSPY is out of Stanford, and it's much more programmable. So anyway. And you know, the other thing too is why does LLMs have to be orchestrated? Well, because in the real world, you're not going to have more than one. You're going to have ones that do red teaming. You're going to have ones that do, you know, governance and clearing. You're going to have audit control. You want to make sure. Like one example that I like to use is if you're Goldman Sachs and you're building an internal chatbot or co-pilot for high-frequency traders or algorithmic traders. Like, you want something at the end so that any of the code that gets produced to the people who should be able to see those algorithms that make billions of dollars never gets out in the wild. So maybe that last LLM is a set of questions that the answer should never. You know, I don't know this to be true, but imagine like Nike, and you never want LeBron's contract to be out in the wild. So maybe there's a sort of like a question to ask questions about his contract, and that's the gate. Right, so this idea of like using LLMs to do kind of what we do, gate. Observability is really interesting because the way, until I got into this about a year and a half ago, observability was like Honeycomb or Dynatrace or right, like, and I call it sort of modern observability because observability goes all the way back to control systems, right? But the thing is, all of these MLOps people that were doing what they call evaluations have all called themselves observability too, okay? But in their world, and I'll just point out Arise, LangChain has a built-in one, there's TrueError, Y Labs, there's a couple of them. But what these do is they don't monitor like the latency and the performance and the CPU. They monitor things like what's the percentage of hallucinations it's giving you? What's the percentage, and it uses a, sort of a 0 to 100 scale, right? That what is the correctness? What's the relevance? What's the bias? And what you do now, think about this as a new form of TDD. I've built a corpus of data that's really important. It's high consequence answers. The answers got to be pretty close to correct every time. And so now what I do is, part of my monitoring now is to put in, as sort of a test-driven development, 100 or 500 questions. And then I get a baseline that the correctness and the relevance is 93, the hallucination is about 4%, right? And now as I continue to add to the data, I'm monitoring those baselines. Did I add a bunch of data? It went from 93 to 70%. Ooh, yeah, this is problematic. Let's stop the build, right? Or in this case, stop the model tuning or whatever, right? So, and again, this is how you tame the beast, if you will. You know, all that stuff about, oh, we can't use that because. No, you can, but like the amount of effort you put into all the things about how you build the data, how you train the data, and how you evaluate the data, again, they call it observability. And this is interesting. This is the Arise solution. But you can see there right off the bat, you instrument it in your code, and it will automatically pick. This is a LangChain implementation. Llama Index, they all have these hooks that you can instrument the orchestration tools. And you can see like there, like it's got a 0.67% hallucination. Now I was trying to make hallucinations for this, so and then it had correctness, and then what they call an NDCG, which is another sort of similarity scoring. So like those are my baselines for these 3 questions, right? And then like what's really cool is, I don't know if I left a slide in. I did leave some slides in. It actually, some of the ones will actually do a hallucination, not only tell you that you hallucinate, but try to explain why it thinks it was hallucinating. And this is important because sometimes hallucinations are hallucinations. I made that up. But the point is, it might be okay. Like in my book, it said that I should have said more about a certain subject, and in my book, I didn't need to say anymore. But it was interpreting. But in other cases, I found in my book where it said, I think that second one, it tells me that it was a little confusing. Man, I wish I would have had this when I was going through my revs, because like it's like a human reading your book, and it's telling you. But think about all the ways you can sort of understand how people do Q&A, and this is like an army of people, in a sense. I mean, I don't know. I think it's fascinating. And then these are some of the vector databases. So what the vector databases are is, if you think about what you get from like GPT-4, like it's what they call foundational model or frontier model. Like it exists. You only get what's in it at the time, the next one, all right? But if I want to ask it about my company's internal policy for how do we do SOPs for governance and risk, it's either going to make stuff up or it's going to say, I don't know, depending on how you say your prompt. But if I want to make that data behave the same way that GPT does for like, tell me all about Abraham Lincoln, what I do is I take my data and I put it in an embedding format that is, remember the embeddings was the vectorized data, and it's all simple stuff. If I can do it, anybody can do it. The embeddings, and I put it in the same embedding format as the sort of foundational model that I'm sort of attaching to. And I'm literally creating a chat GPT where my data is sort of the prefix of the first set of data that it's going to answer questions from. And this, again, how I learned this is I use my book. And I knew what was in my book or wasn't in the book, so I was able to sort of navigate all what a hallucination was. And so MongoDB, the reason they're my client, but I went to them because I used all of them, and I think they are best suited for the enterprise. And that's all I care about. I don't care about startups. I care about large banks. And I think that the way they combine the document object, the full text search, and now the embeddings all in one space, and I won't make this a pitch, but I will say that I think they're the best suited for the enterprise, and that's why I chose them over a couple of the other new vendors. And what you need to know, though, at the end of the day, this is commodity. So my best advice to them is don't go out and try to be the best vector database, because every vector database is out there, and there's not over 100 now, are going to tell you they're the best. Most of them are using Lucene, and Lucene has had this in it. This is open source and free. You can run this on your own. You can run this on Amazon. If you just load Lucene, but so anybody who was using Lucene for full search text already had it. In fact, some of the vendors didn't even know. They're like, "Hey, do you have a vector database?" And like, "No, we got to build." Like, "Are you using Lucene? You have one. Just turn that on." So, and that's called hierarchical navigable small world graph. It's another interesting conversation to see how it clusters the navigation of the vectors. This is an important slide. I won't have a crazy amount of time, but I would look at, again, it looks like I'm pitching Mongo, but the guy who wrote the Mongo's document, they got their own chatbot for their documentation, he did an incredible job. And he documents, and it isn't just him, it's a whole bunch of stuff out there called Naive Rag, and it literally goes through like a lot of the things. It's, like some of you probably loaded a PDF into Claude and it gave amazing answers. And like what I tell enterprises is, if you want to build a chatbot that's going to recommend at central headquarters what's the best place to get lunch, don't listen to anything on this slide, because it's that easy to just load it into a vector database and it'll get really good answers. But if you're a company that I've worked with, I'm helping sort of Sherpa this project, where the people climb up in telephone poles and have to do really complex configurations and weird situations, and if they get the wires crossed, they might die. I want to make sure I do everything on this list. I do end-to-end processing, running evaluations. I'm really thinking through the data, looking at the data, changing the sizing of how they're chunked in the vectors. And so that article does an amazing, and red teaming. So that's the other thing, right? If you're going to take data that's like high consequence data, maybe it's something that could get you sort of destroy your brand, right? The wrong answer, like look at the Air Canada thing, right? Like, and Air Canada's kind of a joke because it was way before GPT-3 was out, right? So like the whole thing about it being, sort of the narrative of the world, it was probably just Java code or JavaScript code, right? But the point is, a bad answer could really sort of tarnish your brand, right? And maybe put you out of business, right? So red teaming is interesting. There's a great paper on this. You just Google red teaming and generative AI. Is like the same way we do like dark launches and canary deploys. What I'll do is I'll say I have really important data and I'll make it available to all of my team. Then maybe all of a division. And I'll let them constantly do the feedback on the questions. Hey, this is giving me the wrong answer. Before you send it out to the whole company, before you send it out to the state of New Jersey, before you send it out to all your customers. So it's a similar concept, right? And anyway, I got my book out there on Hugging Face. So, and this is just some demo code. I'm probably not going to have enough time to show demos. I could, in an open space, if you want to see the demo versions of these things. They're all in the workshop. Well, this is one where like you run it, and so this is kind of interesting. So one of the things you got to do is when you're sort of working with your data or the data that you want to fine tune, you want to find different embedding models to work with. You don't have to use GPT-4. Like in some cases, you can get way better performance and higher similarity or similar similarities with an open source, like even the Beijing one. That's very popular, and so for small subsets of data, I can do that. I don't even need an orchestrator, and I can build a really powerful GPT that is very low cost. I don't have to use OpenAI, all that stuff, right? I don't have to pay any charge for the transactions. But it's all a matter of performance versus, how correct and at the end of the day, the GPT-4s and the Claudes and the Anthropics are going to have the better performance in their models, in their embedding models. But at the end of the day, not like sort of mileage varies, right? So you notice in that code, I play around with asking questions and checking similarity scores based on different models, different embedding models. And then this is probably the most important of this workshop slide is what I found is that not all data is equal like that, star. But when you're dealing with creating your own data, you sort of vector database, you just have to play. You can read an article and say, "Oh, always chunk at 400." Like chunking is like how you're going to carve it up before it gets vectorized. But then and then you take your data and that's baloney. In this data, it chunks at 200. In fact, what I showed is if I use my whole book, I took the numbers, the hallucination, but then I did the human in the middle to look at the answer as well. And this is why the red teaming is important, right? So what I found was it was actually PDF chunking. Because like they call it semantic chunking, there's markdown, sometimes turning your sort of text or whatever you have into markdown can be a high improvement. But I found for my book, the best was this, take apart one, cut up the parts into their own vectors, and it had, even though it was a little less on some scores, it was the best answers. Yeah, all right, so we're winding down here. The model providers, so I kind of put little license liberty or whatever here, OpenAI, Microsoft, but they have their own. Gemini you can get without being running on Google, but you can certainly do Anthropic's Claude without Bedrock. But these are the ones that seem to be pairing up really well. So I figured it was save a slide, save 30 seconds. And then the small language models are really cool. Oh man, I'm going to get clobbered. The small language models are really interesting because they can solve really fine-tuned with really low cost. So this is really interesting that's happening now. So Google SLMs and Microsoft is 5.3 ones are, they got Gemma and Minstrel is red hot, but the Microsoft ones are really, really interesting. This is the workshop. Take a picture of it. We're going to be done here in a minute. If you want everything I did, the 4-hour version of this is in there. Here's 1, 2, 3, 4. It's not a paid for class, so you find a bug, just do a pull request. But yeah, it's if you really want to go through the longer version of this, it's all out there. It's open source, bang, bang, bang. And yeah, I'm basically done. There's some demos that I could have showed you on. There's some interesting. Hugging Face is interesting. All right, I'm going to take. I got 2 seconds. The Hugging Face is really interesting. I got to show you this. I'm sorry. Because the Hugging Face is like how you can really learn this stuff really quick, and and again, Mongo has it, but like this is a really cool. It's a vector database in Mongo of all the restaurants and their ratings in New York, and you can ask questions like, give me Indian food within certain radius, certain things, and then it actually calls the Google API map. But here's the cool part: all the code's out there. So you just go to app.py and I take this code. I'm like, all right, let me try to run it in Collab, a notebook, see what it runs like, So you start finding the apps out there, and what the beauty of it is, you go to GitHub and look at it and say, okay, they don't have a good README. How am I going to install this crazy thing, right? Well, but here it's like everything's built together. So Hugging Face is becoming sort of in a sense, the new Gen AI Hugging Face. Anyway, that's all I got, and I wish I could give you